and I am also the we have IIC institutions innovation cell, and I am the ambassador for civil engineering department. Because nowadays not only teaching research, you have whatever the research you are doing, that you have to business. That means you have to sell yourself. Only if I say I am good in teaching, I am good in research, it is not sufficient. You have to say what research you are doing and how you are selling yourself. Okay, is it visible, these slides? Hello, hello, these slides
It's
are
okay, sir.
visible?
Yeah, it's
Right,
okay,
right,
sir. It's okay.
right. Okay, so mainly here I am going to
Sir,
concentrate mainly on the
sir, only first slide is showing, sir. Second slide is not coming.
second slide is not coming now.
Yes, sir. Ah, okay, sir. Okay, sir.
Okay, then I will go on changing the slide one by one. That's why I am asking. Okay, now it is visible now, timeline of concrete and cement history.
Yes, sir. Yes, it's visible, sir.
Okay,
It's visible,
see
sir.
if you see, I will discuss here basically what is the history of the concrete, and now where we are and where we started. Okay, right.
Okay, sir.
And if you see, in the Romans first invented the concrete, hydraulic cement based concrete. Before that, no cement, only we are going to use the mortar and lime mortar. So with that only we are going to do. But after that there is a improvement in the concrete technology. Instead of lime mortar, slowly we came into the cement mortar. Okay, just 1 minute. Hello sir. Sir, వీడియో అది నేనైతే స్విచ్ ఆన్‌లోనే పెట్టాను సార్. ఒక్క నిమిషం మళ్ళీ ఆఫ్ ఆఫ్ చేసి ఆన్ చేయనా? ఒక్కసారి చూస్తా ఉండండి. ఆహా! ఓకే. ఓకే. ఆహాహా! యెస్ సార్. యెస్ సార్. నా కెమెరా ఓకే. ఓకే. ఆఫ్‌లో ఉంది. ఆన్ చేశా. రైట్ సార్. హుహుహు. హ్మ్. ఓకే సార్. యాహ్! So now we will discuss about the concrete. So if you take the concrete, concrete is the combination of steel, cement. Hello?
Okay, sir. You can continue, sir.
Okay, okay, right. Actually, if I go to the presentation mode, you are not able to see, na? Let us. Now it is okay.
Sir, everything is okay, sir.
Right, right. Thank you. So basically, we in the particularly in India, we are very much habituated with the concrete. Construction means actually in India, we are going to do with the concrete only, right? So I think these slides are not going to show. So let us see what are the advantages or recent advances and trends in the concrete technology. First we will see, then after that what are the different methods of making new concretes. Because nowadays only working with the regular cement, sand, coarse aggregate is not allowed. Because you know that if I want to work on the concrete, then I am going indirectly I am going to produce, if I am using a cement means indirectly I am going to produce the carbon dioxide, but it is not useful, not it is very harmful to the industry. Okay, so that's why we have to think for alternatives. What are the alternatives I can go? So here if you see, I can go for the, initially we started with the cement mortar of lime mortar, then we went to the cement concrete. Because already because necessity is the importance of the invention. So based on the necessity, slowly we moved to the cement concrete. Afterwards, even the regular cement concrete, only if it is giving M20 grade, M30, M40, it is not sufficient. Then we went to the high strength concrete, then high performance concrete, then fiber reinforced concrete, like that, self compacting concrete, self curing concrete, then geopolymer concrete, and all these things. So we will see the all the updates in the concrete.
Excuse me, sir. Your
Okay.
screen is not visible, sir.
My screen.
Okay. Now it is visible, sir. Okay, sir.
Okay. See, if you take the fiber reinforced concrete, so what is the advantage of fiber reinforced concrete and where we will use it, I will tell you first. Before that, we will see what are the different fibers, types of fibers we have. So we have steel fiber, we have glass fiber, asbestos fiber, polypropylene fiber, carbon fiber, armored fiber, like that. So many new things are coming. Some are useful in the micro level, some are useful in the macro level, like that. So basically, wherever I want to develop the tensile strength of the concrete, I want to increase the modulus of rupture, Young's modulus, flexural strength values, then automatically I prefer the fiber reinforced concrete. Suppose if you take the example of you are constructing some slab, and there if it is a there the rainy period is very high, there is a chance of leakage of water from the slab, then you can go for the fiber reinforced concrete. If you use the fiber reinforced concrete, the advantage is it is going to arrest the cracks, and it is going to make a concrete in such a way that there is no leakage of concrete, because fibers are very good in arresting the cracks, and they are going to have very good bonding with the concrete. So like that, this is going to be useful. If you see the fiber reinforced concrete stress strain diagram, this after ultimate, if you see the area under this curve, if you take A1 and A2, so indirectly we are improving the ductility of the concrete. Ductility means toughness of the concrete. Indirectly I can say toughness of the concrete, total area divided by A1 plus A2 divided by area of A1, if you say, that will give you the toughness of the concrete. So uh, like that, here you can see without fibers it is going to be very brittle, but with fibers this is called rupturing of the concrete, or flexural rigidity is going to be very very improved by utilizing this fiber reinforced concrete. So for that, nowadays so many types of fibers are came now. Even in the FRP, means in the retrofitting techniques also, we are going to use these sheets. So this is a very wonderful material which is going to use you the improve the tensile properties, modulus of rupture, flexural properties of the concrete. Okay. So based on the requirement, we are going to see whether fiber reinforced concrete is used or not. Next, if you come to the high strength concrete, see, already we discussed about the normal strength concrete. See, in the normal strength concrete, we can achieve up to a grade of M50 or M55. After that, I am not able to develop the concrete. Then, so suppose if you are in metropolitan cities, or where the land cost is very high, in that cases, definitely we have to go for high rise buildings. Let us say G plus 10, G plus 20, G plus 30, like that. So if you are going like that, automatically you have to develop a high strength concrete, which is going to have the higher strength characteristics. Mainly in the columns, we are going to use M60, M80, like that. Suppose if I am constructing a in New Mumbai, some construction, then definitely it is going to be a G plus 50 or G plus 80. I cannot waste my land. So for that purpose, definitely I have to think about the high strength concrete. So in case of high strength concrete, what we are going to see, obviously there are certain conditions. If I want to get a high strength concrete, I have to maintain the low water cement ratio, then addition of fine pozzolana materials like silica fume, fly ash, GGBS, metacoilin, like that, ricus gas, like that. We have to add some pozzolanas to improve the pozzolana activity and to get the high strength concrete. See, only if I use using the cement, if I am developing the strength, then automatically it is going to be not economical, and even there is a burden on the concrete also. Only cement is increasing, then you are going to see so many other problems. But if you utilize this binder, because it is a byproduct. Well, if you take a fly ash or ggps or anything, it is a byproduct. So if you utilize this, you are going to get two ways of solution to the problem. One way you are showing you are utilizing the waste, and another way you are reducing the cement content and you are utilizing it as a binder, so that durability properties are going to be increased when you are adding these pozzolanas. Because of this pozzolanic action, strength, there is a improvement in the strength, and additionally there is a pozzolanic reaction, so they are going to be very useful. Only whatever the cement it is required for the hydration process, you use only that much of cement. Then afterwards, then you go for uh, using this uh, pozzolanic materials. Okay, I think right. So now, if you go to the high strength concrete, how to prepare it? What are the simple thing? What is the difference between the normal strength concrete and high strength concrete? If you know, see, basically, if I want to get more benefit, means definitely there should be some limitations on the material usage. Obviously, when I am saying it is used for the high rise buildings, then there will be the sizes are going to be slendered. So obviously, there is a limitation on the coarse aggregate content. That means the size of the coarse aggregate is going to be reduced maximum of 16 or less. Otherwise I will go for the 12 only. And definitely I am going to use the supplement ECS materials like fly ash, silica film and all this, but different dosages I will fix based on the different type of the material. Suppose if it is a silica fume, because silica film is going to have the high water absorption capacity, high range range admixtures are used in case of silica film added as a super plasticizer. That's why its dosage is only 5 to 10% only. But if I am using fly ash, I can go up to 20 to 25%, even up to 30% also I can use. Like that, based on the different silica film, fly ash, ggbs, all are ashes only, but there is small change in the collection process. How you are collecting, based on that they are given a different name. All are ashes only. Nowadays even this JSW is using the slag also. Slag is also one type of a ash. But how you are collecting, how the fineness is there, based on that we are giving different naming to these materials. Obviously I told you, in case of high rise buildings, let us say if it is a G plus 80 or G plus 100,